No, I don't know. Hello everyone, welcome back to another remote sensing lecture video. In this lecture video, we're going to talk about using classification in change detection. Classification in change detection. Now I want to stress here that this is different from the map-to-map comparisons that we talked about previously. This is actually applying classification algorithms, whether they're unsupervised with ISO data or k-means, or supervised with random forest, support vector machine, maximum likelihood, right? It's applying those to what's called a multitemporal image. So let's sort of recap what I just said. Right? Classification in change detection in this case is talking about applying a classification to a multitemporal image. Right, applying a classification to a multitemporal image. Well, what is a multitemporal image? A multitemporal image is just a way of saying that we have a single image consisting of bands covering the two different time periods. Right, so up to this point, we've dealt with two different images. We had time 1 and we had time 2, and we did something with them. We either did a classification and then compared the way that the classes changed. That was the map to map. Or we did this idea that we could do image differencing, where we subtracted pixels values from one time from another, and the way that the differences were could tell us, what the change was. Whereas in this case, right, we're actually going to use what's called a multitemporal image, where both time periods are actually stacked into a single image. So you have the bands from both images, time 1 and time 2, compressed into a single image. So it would have more bands than before. So let's just sketch out what that looks like, because I think it's a little bit easier to look at it sort of schematically. So let's use our simple 4 pixel image here. Okay, so we've got 4 pixels. Right, and so we're going to use our first, we're going to have red, green, and blue as the wavelength regions that we're capturing. Okay? So this would be red, this would be green, this would be blue. Alright, we've seen this before. This hopefully should not be new to anyone. The difference here is that this right here is now time 1. And not temp, time. This is now time 1, right, because we're dealing with a multitemporal image. Then in the same image, we would have 3 additional bands. Right, 1, 2, and 3, right? So this would be, again, red, green, and this would be blue, right? But instead, these 3 bands now would be time 2. But I want to stress here, this is all one image. Right, so this is one image with 6 bands. The first 3 bands represent time 1. The second 3 bands represent time 2. So hopefully that makes sense. I know this is kind of a jump from what we've been talking about before, but I just want to stress here. 6 bands, 1 image, 2 time periods. Okay? So what I want to do now is I want to throw in a couple of just sort of made up spectral responses. So let's make up some pixel values so we can talk about how change would look like in this context. Okay, so let's assume that this pixel value right here had a value of, say, 35. Let's say it jumps up to 85 and then drops back down to, say, 37 here. So this is going to be vegetation. These 3 pixels are going to be, I'm telling you, they're vegetation. All right, so this is going to be something similar. Let's say 38, 81, and let's say this one is going to be 39. Right. This pixel here is going to be urban, so we're just going to kind of keep it pretty consistent. We'll say it's 100, 102, 103. Sure. Now this pixel will be bare forest, or bare ground. So it's going to have pixel values of, let's say, 50, 75, and 50. Okay. So we've got 2 forest pixels, an urban pixel, and then a bare ground pixel. Okay. So let's go ahead and look at time 2. And let's just say, for the sake of change detection, that this pixel right here, so this upper left pixel, let's say this pixel was burned by a fire. And this pixel here was actually grown into vegetation between the 2 time periods. So if this was burned by a fire, it's going to have much lower. So let's say 1, 3, and 2. Right, it's been burned, so this is now burnt, charred black earth. This lower left pixel here, we'll say that it remains unchanged. It didn't get burned. So that's going to be 38, 81, and 39. So its pixel values don't change much at all. This lower right pixel, we'll say this became vegetation, so we're going to mirror the pixel values of these 2. So we'll say it's, say, 37, 83, and 40. Sure, that seems pretty close. And then this upper right pixel will say this remains unchanged. 102, 102, and 103. Okay, so again, I made these pixel values up, but they represent this idea that we have 4 pixels, each undergoing some type of change or no change at all. And what I want to sort of describe here is what happens when we put this image into a classification. Right, what happens when we put this 6-band, 2-time, multitemporal image stack into a classification? So let's just take a step back for a second. And let's talk about what would happen if we put just time 1 into an image, into a classification. What do we think might come out? Well, we might say these 2 pixels are forest, this pixel is urban, and this pixel is bare soil. So we would have 3 classes in theory, right? Forest, urban, and soil. Okay. What about time 2? If we were to put time 2 into a classification, right, we would get burned earth, forest, and urban. So we would again get 3 classes. But what happens when we put this entire thing into a classification? And that's actually where we're going to stop the video. I want to make sure that we get a lot of time to dig through what happens to each of these pixels and why it happens, so that you have a good understanding of why this approach works and how it's different from the map-to-map comparison. So hopefully that makes sense, and if you have any questions, please reach out. Thank you.